Okay, now let's discuss further. Now we will discuss about the concept of antigen and antibody. Concept of antigen and antibody. With regards to antigen A, B, AB. There is a very beautiful concept in this one. Normally what happens, we all know that antigen is any substance, and against this substance, or we can say against this substance, our body will produce antibodies. So these antibodies will attack these foreign substances and will kill them or will destroy them. This we all know very well. But what happens, we all know that our body has also its own antigens. So this A, B and AB, these are known as our own antigens. So why not these antibodies kill these antigens? So there is the clinical concept behind it. Let's understand it very well. So all the antibody forming cells, these are B cells or T cells. We should not say antibody forming cells. This is B cell is antibody forming cell, and T cell is an immune cell, I should say. So cells, all the antibody forming cells, cells from immune system like T cells, B cells, develop in the presence of individual's own antigens. Suppose this is a person, okay, and from the fetal life onwards, he has X antigen, Y antigen, Z antigen, or we can say P antigen. Okay, he has X, Y, Z and P, 4 types of antigens. Now the development of these X, Y, Z and P antigens will be in the presence of lymphocytes, that is B and T. Okay, so what happens that in early life, samples of one own antigens, suppose X antigen is developing. Here is T lymphocyte. What happens during the phase of development, a small sample of this antigen will be presented to T lymphocyte. Okay, T lymphocytes, or we can say B lymphocyte. Okay, this is an antibody forming cell. We all know who produces antibody in our body. B cells, that are B lymphocytes, produce antibody in our cells. So and then immune system react accordingly, like they will react or not. Suppose this is first lymphocyte, second lymphocyte and third lymphocyte. First lymphocyte, second and third. Okay, now suppose this X antigen is recognized by second lymphocyte. Now what I am saying, please keep it in mind, this X antigen is recognized unfortunately by this second lymphocyte. Okay, so if second lymphocyte recognize this X antigen, then during the phase of development, this lymphocyte will start producing antibody against X antigen. Okay, this is what we were saying. Normally what happens, that antibodies, or we can say X, B lymphocytes or B lymphocytes mainly, will produce antibodies against the antigens, any foreign antigens. But this is an X antigen. So how our body recognize that yes, this X antigen belongs to me, this is my family, I should not kill this antigen. So during the phase of development, a small part of this X antigen will be presented to this lymphocyte, and immediately if this lymphocyte will recognize this X antigen, this second lymphocyte will be immediately destroyed. So suppose 1, 2, 3, 3 lymphocytes are there. Second lymphocyte recognize X antigen, and immediately this lymphocyte will be destroyed, the dead. So now against the X antigen, no antibodies will be produced and this X antigen will survive. This is the main concept. Now, one more thing. But in the end, also then millions and millions of lymphocytes are, and this collection of lymphocytes cannot recognize own antigens but can recognize foreign antigens. So millions and millions of antigens are present. So these lymphocytes are present. So these lymphocytes will only recognize foreign antigens and will not recognize our own antigens, our own family. Why? Because during the phase of development, a small part of this antigens, or we can say X antigen, will be presented to these lymphocytes, and those lymphocytes, or we can say any lymphocyte, those lymphocytes recognize antigen, those lymphocytes will be destroyed. So that is why, usually speaking, our immune system does not attack our own tissue. Suppose any tissue you have, suppose you have any kidney cell. This kidney cell has Y antigen and here lymphocyte. So why does not this lymphocyte attack this one? Because during the phase of development of this lymphocyte, a small portion of this kidney cell will be presented to this lymphocyte, and if it recognizes this one, then this will be destroyed. That's why we speak that our own immune system does not attack our own tissue until and unless there is a disease. So many diseases are there in which our immune system starts to react with our own antigens and destroys our antigens. That are the immune diseases. But our discussion is limited up to here. So in our immune system, those lymphocytes which recognize A antigens are killed, and that's why antibodies cannot be produced against A antigen. So yeah, we have antigen A. So during the phase of development, body recognize antigen A as our, so no anti-A. Understood? Similarly, antigen B, no anti-B. And in case of antigen A, B, because here both antigens are present. Antigen A is also present and antigen B is also present. So in those who have antigen AB, or we can say A and B both, and we can say those who have AB blood group, on their red blood cell antigen A is also present and antigen B is also present. So during the phase of development, what happens that their body will present antigen A also to the lymphocyte and antigen B also to the lymphocyte. So lymphocytes which recognize A antigen and B antigen both will be destroyed, and there will be no antibodies produced against anti-B. So no antibodies. Here I am saying no antibodies. Here I am saying no anti-A. Here anti-B can be present. Here I am saying no anti-B. Here anti-A can be present. Here I am saying no antibodies at all. It means because antigen A is also presented during the phase of development, and antigen A is also presented during the phase of development, and antigen B is also presented during the phase of development. So no antibodies will be produced. But what happens in case of blood group O? We are saying in case of blood group O, in case of blood group O, what is the antigen secret of blood group O? There are no antigen, only H substance. So in case of blood group O or H substance, no antigens were present on RBC. So here RBC, here are no antigens. This is blank, completely blank. So nothing is presented to lymphocyte during the phase of development. If nothing is present, so these lymphocytes produce both anti-A and anti-B antibodies. So this is the secret. So in case of blood group O, no antigens. So no antigens will be presented during the phase of development. Hence anti-A will be positive. It means present, and anti-B will be positive. So this is the case. In case of antigen A, no anti-A will be produced. Concept is crystal clear. In case of antigen B, no anti-B will be present. Concept is crystal clear. In case of antigen AB, if I am saying antigen A, antigen B, antigen AB, it means blood group A, blood group B, and blood group AB. So in case of blood group O, only H substance, no antigen will be presented during the phase of development. So body recognize antigen A and antigen B both as foreign, and lymphocytes are present, and they will produce antigen A antibody A and antibody B. Now there is a question. Here I am saying, here I was saying that here no anti-A antibody but anti-B can be present. Here no anti-B but anti-A can be present. So there is a question. Person with antigen A or blood group A has or made B antibodies. Why? What's the reason behind it? This is the main question. Suppose I am having blood group A. This is clear that I am not producing anti-A antibodies due to the selection of lymphocytes. But I am producing anti-B antibodies. I am having blood group A and I am producing anti-B antibodies. What's the reason? Now what happens that after the birth, when we eat food, we settled bacteria. There are many settled bacteria we inhale many bacteria from the outside. So these bacteria also have similar antigen A and antigen B. Suppose the bacteria is there. It has also antigen A. It has also antigen B. Okay. But what happens? This A antigen is already recognized as self. This antigen A was already recognized as self. So body can't produce anti-A antibodies. This is what I made crystal clear. But in case of here antigen B, this antigen B is present and that is also foreign. So body didn't recognize this antigen B, and this was not presented during the phase of development. So body will produce anti-B. So person having antigen A, or we can say blood group A, will produce anti-B antibodies. This clinical concept, this clinical correlate will be discussed in more deep and with more correlations when we discuss that if a person has a blood group A, then why he can receive blood from person with having blood group B and why can't. If yes, why, and if not, why can't. So we'll discuss at that time. So this is what made clear. That's why person with blood group A antigen has anti-B antibodies. Similarly with B, it has anti-B and anti-A antibodies. Similar with AB, has neither anti-A, anti-B, because both antigens were recognized as ons. And similar with O, has anti-A and antibody both, because both are recognized as AB, as foreign antigens, and previously they were not exposed to immune system. That's why antibodies will be produced. Now one more main thing, that these antibodies are found in plasma. All the antibodies which are presented against A, B or AB, they both are present in, all antibodies are present in plasma. Clear? Usually specific antibodies are formed against a particular antigen when they are exposed to that antigen. This is also clear. Blood group antigens antibodies are naturally occurring antibodies as they are formed without prior exposure to the antigen. So if any antigen, blood group antigen antibodies are naturally occurring, okay, antibodies as they are formed without prior exposure. This is also clear. So but proper mechanism of development of blood group antibodies are not known, but yes, they are produced, and we see in cases also that why person can receive blood, why can't he receive the blood. Now time of appearance, I have already told you that all these antibodies are appear in the second week of neonatal life. So antibodies appear in the second week of neonatal life. That's it. So there is a law which is known as Landsteiner's law. Landsteiner's law. What this law says or define, the law states that if a particular antigen is present on the red cell membrane of an individual, the corresponding antibody must be absent in his plasma. Suppose if A antigen is present, then the corresponding antibody, which is the corresponding antibody? That is anti-A. It should be absent in his plasma. That is what we have discussed. And I have already told you about agglutination and